Hello and welcome to the first video of this section, Theoretical Background. In this section we'll explore the use of cluster analysis to find hidden patterns in our data. In particular, this video will cover the theoretical background you need to understand for what we'll do later in this section. Cluster analysis belongs to a class of techniques referred to as unsupervised learning. Therefore, we'll start by describing this aspect. Then we'll focus on cluster analysis, presenting the two most famous techniques, K-means clustering and hierarchical clustering. Unsupervised learning refers to a set of techniques that we can use to find patterns in data with no labels. Imagine you have a set of objects and you do not know their names or their purpose. Clearly, you cannot classify these objects precisely because you've never seen them before in your life. However, what you can do is group these objects according to common features.
For example, if two objects have similar shapes or colors, you could try to put them in the same group.
You don't know the purpose of the objects in each group, but you know that within groups there are objects that share some features.
Therefore, objects within groups are somehow similar.
This is, in simple terms, the purpose of clustering algorithms. Clustering refers to a set of techniques used to group data. The purpose of the algorithm is to define these groups in such a way as to maximize the similarities to the same cluster and maximize the differences between clusters. Everything is based on how the algorithm judges similarities between points. The most common way of computing differences between points is calculating the squared Euclidean distance.
Let's say we want to divide some points based on their geographical location. We can calculate the Euclidean distance
by calculating the square differences between their longitude and latitude,
and then adding the two results.
This same equation can be used with, for example, let's say we want to cluster points based on the average wind speed. The Euclidean distance will be calculated subtracting the wind speed of the first point from the speed of the second.
We will talk more about this aspect in the following videos. Probably the most famous clustering algorithm is the K-mean clustering, which I use for the example of this page of my blog.
In this algorithm, we need to specify the number of clusters before doing the analysis. Therefore, we need to have some ideas about possible clusters even before we use the algorithm. However, there are ways to determine experimentally the number of clusters. The way this algorithm works is very simple. Let's say that we want to cluster these points into two groups. The first step is assigning each point to one cluster. Then the algorithm calculates the centroid of the two clusters.
In step 3, the points are regrouped based on their distance from the two centroids. Then the centroid of the new clusters are recalculated. This process of grouping and calculating the centroids continues until the location of the centroids does not change.
Another commonly used clustering is hierarchical clustering.
In this case, we do not have to decide the number of clusters before the analysis. The algorithm calculates similarities between all pairs and then plot them on a dendrogram.
Plots them on a dendrogram, which is a simple tree diagram. We'll see exactly what. By interpreting this plot, we can then figure out the optimal number of clusters in our data.
The algorithm assumes that each point is a cluster with one object.
It then starts by grouping similar clusters,
i.e. clusters with other clusters inside them.
The process stops when only one large cluster remains. This process can be presented in a dendrogram,
which we can use to divide our data. We will talk more about this aspect in the video.
To conclude this section, I put together some additional references that I suggest you to look because they may help you in further increase your understanding of clustering algorithms.
This concludes the first video of the section where we learn some theoretical aspects of clustering.